Hi, Professor. This is Dan Riseman with assignment 1.8. This assignment made me rethink parallelism. I always used to think that parallelism is just where it's equidistant and not intersecting. I always thought about it in two space and the idea that it would be equidistant at all points. But the definition I use with parallelism here is what it means that there is a line segment that is perpendicular to both of those lines. So in doing that for 3b, concentric squares and concentric cubes, it may seem at first that they are parallel. However, if you create your line segment and you drag it to the corners of the smaller square or cube, and then you move it around, you'll notice that the line segment is no longer touching the larger square or cube. So here's an example of where it touched. And then here's an example as I move it around, it no longer touches. So as a result, these guys are not parallel. The two objects are no longer maintaining the same distance from each other, and the line segment is not perpendicular to both of the lines. You can see that. It's kind of an interesting idea. So it's not parallel. Same thing with concentric cubes. You can see there it worked, and there it doesn't work in the corner. So not working, seem to be working, but not working, therefore not parallel. For C, the question is asking two parabolas, y is equal x squared and y is equal x squared plus 4. Now, it seems that they would be parallel initially because all you're doing is shifting one parabola up 4 units. However, this is not the case due to our definition. If we draw a line segment that is parallel to the vertex of one of the parabolas and the other parabola, and then drag it, we'll notice the line segment would be too long as the parabolas get closer together as they move up. Therefore, these two parabolas are not parallel, as you can see here. There it seems like it might work out. There's our line segment, but too long. Would not be parallel. For D, the helixes are a pretty interesting idea, I think, of DNA. Now with this guy, you got to think about the definition of parallelism. With this situation, you can create your line segment, but the helix is going to be essentially a spiral. If we look at a helix down the axes it revolves around, it will look like a circle. And since the circle goes into another direction, we could say that the helix would wrap around an imaginary cylinder that goes along the same axes. And because these two helixes are congruent, we can assume that they have the same degree of rotation, translation about the same axes, and are 180 degrees out of phase. Therefore, the two helixes would be wrapping around the same cylinder at opposite ends of the diameter. This could be used, that diameter could be used as our perpendicular line segment. So I drew something here. It's not perfect, but you can get the idea. These line segments are going to be the same distance, and they're going to prove that this guy is going to be parallel. And it's kind of interesting. I never considered it to be parallel, but it is. It would be parallel. For two distinct rhumb lines with the same bearing on a perfect sphere, this is similar to what we just did with 3D, but instead of going around a hypothetical cylinder, we're going around a hypothetical sphere. But these guys are not going to be parallel. The reason they're not going to be parallel is that if you look at the poles, this guy is going to be completely different than this guy. The line segments must be much smaller near the poles. Therefore, this guy, which is kind of a cool drawing, is not going to be parallel. Professor, I hope to speak with you soon. This was a good assignment, and thank you.